Okay, shall we start? Alright, in connected rates of change, right? Okay, maybe before we go into connected rates of change, we understand that dy over dx, okay, is the rate of change of y with respect to x. Okay, WRT as in with respect to, okay, just writing it in short form. So this is what we understand, okay, in a very broad term, but in a more application kind of term, we know that dy over dx is also seen as gradient itself, right? Okay, so what if x and y actually vary, okay, according to time? Okay, that means maybe x is in terms of time or y is in terms of time, okay, t itself. Then we will apply our chain rule. Okay, that tells us that dy over dt, that means if you're differentiating y with respect to t, it will be equals to, we differentiate y with respect to x first times differentiate x with respect to t. Okay, how is this your chain rule application? Let's go back to understanding how chain rule applies. Okay, so for example, if I have y equals to 2x minus 3 to the power of 3, we know that, okay, in applying our chain rule, we will first bring down the power, keep the base, then after that, power minus 1. By doing this itself, okay, we are actually differentiating using our power rule for the overall function first. Then after that, in our chain rule, we know that we have to differentiate the inside, which is going to give us 2. Okay, so what we did here is that we look at the outside, we differentiate the outside using our power rule, then we differentiate the inside. Okay, this is our understanding about the chain rule so far. Alright, now when we have our y in terms of t, or later on you see some example. Okay, so what this formula is trying to tell us is that basically we are differentiating the outside first, then after that differentiate the inside. Okay, so that is the understanding that we have regarding our connected rates of change. Right? I think it will be clearer if you look at an example. So looking at try 6, we are given that y is equals to x minus 9 times square root 2x plus 5. Okay, the very first part asks us to actually find out what is dy over dx. So what we can do is to perhaps first re-express my x minus 9 times square root 2x plus 5 into its indices form. Okay, like this. Then we do our differentiation using our product rule. Okay, that will result in something like this. So our differentiation leads us to this, yeah? If you want to actually actually simplify it into a single fraction, you can. Okay, that will mean that the right side we need to multiply with the denominator. Sorry, half times 2 is. Thank you, I heard you. My bad. Thank you for pointing it out. So you get this up. Okay. Now the thing that I want to actually cover is part 2. Okay. So part 2 asks for finding the rate of change of y. Okay, what this is actually asking for is dy over dt. Okay, when x is equals to 2 and when x equals to 5.5. Okay, given that x is increasing at a constant rate of 2 units per second. Okay. Now let's break down the information that we are actually given. Okay, so we know what we need to find. We need to find dy over dt, given that x is equals to 2 and x equals to 5.5. The only thing that we probably have trouble understanding is this last part over here. Okay, it says that x is increasing at a constant rate of 2 units per second. What this means and translates to is that dx over dt, okay, because it is 2 units per second, so therefore it will be x units per according to time, so that will be dx over dt. Okay, and because it is increasing, okay, we think about it in positive terms, so therefore dx over dt is actually positive 2 units. I'm intentionally writing the positive over there, although in exam you don't need to actually write down the positive side. Okay, I want all of us to actually be aware that increasing, we take the convention of positive. Okay, so this information tells us that dx over dt is equals to positive 2. Alright, so what we're trying to find is to find out what is dy over dt. Okay, and in order to find out what is dy over dt, currently, okay, we are given y in terms of x. Okay, so based on our chain rule, okay, what we do is we differentiate outside, then we go deeper inside. Okay, so our x could actually be expressed in terms of t, but the question did not tell us that. Okay, so our chain rule will tell us that differentiating on the outside, dy over dt equals to differentiate with respect to x first, then go deeper into the x, okay, multiply with dx over dt. Okay, so that is our chain rule application, right? dy over dt equals to dy over dx times dx over dt. Okay, somehow this notation itself is rather magical. Okay, it does somewhat fulfill our understanding about algebra. Okay, while we cannot do any cancellation, but we do observe that dy over dt, if I so-called cancel away the dx like how I do in my algebra, okay, I do realize that it ends up does give me dy over dt. It is just the magic of this notation itself. Okay, you cannot see this as an algebra. You cannot actually do your cancellation like that. You understand? Okay, it's just the invention. I think it was Leibniz, if I'm not wrong. Okay, I forgot who invented this notation. Alright. Somehow, okay, they invented it in this manner lah. Alright. Okay, if you pursue mathematics at higher levels, okay, you will actually find that differentiation can be represented in many other notations as well. Okay, but in this form of notation, you can actually see this cancellation such that yes, they are actually equal. Okay, so now since we are trying to find dy over dt, we already know what is dy over dx. Okay, and dx over dt, question has also given us a value which is 2. Okay, so dy over dx, we have 3x minus 4 times square root 2x plus 5 times dx over dt is a positive 2. Okay, and that simplifies to 6x minus 8 over square root 2x plus 5. Okay, but this is not the end because question wants you to find out what is dy over dt when x equals to 2. So we find when x equals to 2, substitute inside here, our rate of change of y could be calculated in this manner such that it results in 1 and 1/3. We do the same for x equals to 5.5. And our dy over dt is 6 1/4. Okay. But I don't want us to just stop here in terms of finding the value. Okay, you must know how to interpret these values as well. Okay, while the question only asks for the rate of change, that means the value, sometimes they may also ask you, is it increasing or decreasing? So we see that the values are actually positive values. What we can then conclude is that when x equals to 2, y is increasing. At a constant rate of 1 and 1/3 units per second. Likewise, when x equals to 5.5, okay, y is actually increasing at a constant rate of 6 1/4 units per second as well. Okay. You need to write down the units because if you don't have the units, okay, then you will also be penalized. Okay. we look at try 7? Any questions at that point? Okay. Looking at try 7, right? It says that air is being let out of a spherical balloon. So the let out keyword is very important. I'll explain in a moment. Okay. And it is being let out at a rate of 300 cm cube per second. So by observing the units itself, okay, cm cube would represent volume, per second would mean time. That means that your 300 cm cube per second is a volume with respect to time. Okay, so dV over dt, where V represents volume, T represents time. Okay, the question wants us to find the rate of decrease of the radius. Okay, that will mean that we are looking at the R over dt. Okay, because R will actually represent our radius and T represents our time. And because we're looking for a rate of decrease itself, we are expecting that the R over dt comes out to become a negative value. Okay? When we're talking about air being let out, okay, that means that your balloon itself is decreasing in size. So you must be able to associate the word letting out as decreasing itself. So actually 300 cm cube per second is actually a dV over dt of negative 300. Okay, so these are the things that we can interpret, okay, out of the question itself. Right? In part I, we want to find the rate of decrease, that means your dr over dt when your radius is 2 cm. Okay, so how do we go about solving this question? Okay, let's define all the variables that we have used first, your V, R, and all that, because they are not given information in the question. So let R be the radius. We are given dV over dt equals to negative 300 cm cube per second. Okay, at the end of the day, we know that we are trying to find out what is dr over dt. Okay, so what we're going to do is to apply our chain rule, making use of the chain rule concept to help us to find out what is dr over dt. Okay, so how does dV over dt end up connecting to dr over dt? So this is the whole idea about connecting. That's why this topic is called connected rates of change. Okay, because they're all rates of change, they are being connected together. Okay, so the key thing that we need to realize is that, okay, the formula, so-called formula that we will actually use will be dV over dt equals to dV over dr times dr over dt. Okay, whereby our dr over dt is actually expressed over here. Alright, dV over dt we already have it. The only other challenge is how do we find dV over dr? Okay, question says that this is a spherical balloon. Okay, so it is a sphere. Therefore, you must be able to remember and recall what is the volume of a sphere. Okay, and that will be 4 over 3 pi r cubed. Okay. I hope that you are able to recall this formula. If you have trouble remembering, how I remember is that volume is always cm cube, meter cube, and all that, so it must be a cube. Okay, so must be r cube. Alright, then I remember that there's a 3 here, so there must be a 3 lah. Okay, so that's how I recall. Okay, I don't know whether you have other techniques of recalling, okay, but it's a personal preference. So with this formula, I can now find out what is dV over dr. Okay, 4 over 3 pi is actually the constant. They are just a number. So what we just need to do is to bring down the 3, okay, and then your power minus 1. So that actually gives us 4 pi r squared. Okay. over dt. We also know dv over dr. We want to find dr over dt. So that means that your dr over dt is essentially dv over dt divided by dv over dr. Whereby I shift this to the left hand side by dividing the entire notation. Please do not, write for me dr over dt equals to dv over dt times dr over dv. Please don't write this for me, because you cannot treat this like a fraction where you multiply over the denominator and then after that divide the fraction, divide the numerator. So you cannot treat it like a fraction. So you need to see as dividing, your dv over dr over to the left hand side. Alright? Maybe you cannot see this. Let me write the other way. What I did was dv over dt divided by dv over dr equals to dr over dt. You cannot write dv over dt you cannot write this for me, right? Because we are starting off with our volume, with respect to time, then differentiating volume with respect to r, So continuing from here, dv over dt will be your negative 300 divided by your dv over dr, which is 4 pi r squared. That gives us our dr over dt. In other words, your dr over dt is an expression of negative 300 over 4 pi r squared. And then when r is equals to 2, substituting it into your dr over dt, why r is equals to 2 is because radius is 2 cm. And then you will find that your dr over dt is a negative 75 over 4 pi. Let's give to exact as much as possible. That's why I'm leaving it in terms of pi, rather than to compute the entire value into a calculator to get a decimal. And then, to answer the question 1's rate of decrease. So the rate of decrease of radius is actually 75 over 4 pi cm per second. You need to drop the negative sign. Because it is already a rate of decrease. Right, so the negative is already being represented by the fact that it is a rate of decrease, so you need not put a negative sign anymore. Unless you say that the rate of increase is negative 75 over 4 pi. So if the word increase, then you put in the negative sign. But with the word decrease, you drop the negative sign. Questions? Right? Then we look at part 2. us that the volume is 36 pi cm cube. Okay, we are also trying to find dr over dt. We already know that we are going to be applying this formula whereby dr over dt equals to dv over dt divided by dv over dr. Okay, in fact, in part I, we already found that dr over dt is negative 300 over 4 pi r squared. Okay, but then since you're given the volume, which is 36 pi, we don't know what is the r, we cannot substitute r value inside here. So we need an additional step, okay, whereby the volume is actually negative 300. Okay, so because your volume now is 36 pi, right? And then, sorry, not negative 300, it is 4 over 3 pi r squared. Okay, so 4 over 3 pi r cube equals to 36 pi. That will help us to find out the value of r. That is equals to 27. So we find the value of r already. Then I can find out what is dr over dt. Okay, and that will help us to get the value of negative 25 over 3 pi. Any questions? Okay, so whenever it comes to connected rates of change, right, the key thing is that you must be able to figure out, okay, what is the chain rule formula that you need to actually rely on. Okay, so this is the critical process. Alright, personally, okay, whenever I come up with this formula, okay, some general rules of thumb is that you must actually do a multiplication first. Okay, don't think about your division. Alright? And then also, you can think about it in the algebraic sense at the beginning, okay? Whereby just now I told you that dv over dt is actually dv over dr times dr over dt. Fraction-wise, it does make sense, okay, that dr over dr and dr can actually cancel out such that you're left dv over dt. Okay, it's just that magic of the notation itself, but you cannot actually do the actual cancellation now. Okay, so this is the challenge. Okay, most of the time, whenever it comes to doing your connector rates of change, you must be able to get this first. Okay, then after that, everything else will flow neatly. Okay, so let's do another example. Okay, so let's try to work it out. All right, before I leave it to you to actually do a calculation. It says that a spherical balloon. So again, it's a sphere, okay? And spheres, we know that the volume is 4 over 3 pi r cubed already, okay? It is being inflated, so that means that the balloon is being pumped, okay? And then it is actually growing in size, okay? So, growing in size. Okay, so that the volume after t seconds is 1 plus t square root cm cubed. The question is asking how fast is the radius increasing when the radius is 5 cm. Okay, so given that the volume after t seconds is the expression itself, what it means is that your dv over dt, sorry, your v over v is equals to square root 1 plus t. Okay, that is the volume after t seconds. Okay, so square root 1 plus t. Question is asking how fast is the radius increasing. So that means that you are trying to find out what is dr over dt when the radius is actually 5 cm. Okay, so because you're trying to find out what is dr over dt, okay, we are given v equals to square root 1 plus t. That means that I can find out what is dv over dt. Okay, and since you're talking about a sphere, I can also express my volume in terms of r as well. And that will help us in finding out what is dv over dr. So, having dv over dr, dv over dt, and dr over dt, we need to piece this up together, okay, in order to do my chain rule application. Okay. So, using this fraction, how would the equation actually logically form out? Okay. So, if I want to say, let's say I want to find dr over dt, okay, it is virtually impossible for me to have a product of two things. Okay, because my numerator must be a dr, but I don't have a numerator of dr in the first place. Therefore, it is not possible for my formula to start with dr over dt. Okay, so we need to rechange our plan. Okay, so therefore, we need to have dv over dt. Alright, we try that out. Okay, and dv over dt, we have the numerator to be dv. Okay, and therefore, dv over dr can fit inside here. And then we have our dr over dt. So our chain rule, okay, we will be relying on this equation itself. Okay? So you need to figure out, okay, what is the chain rule application before we proceed with actually all the processes. Okay, so that will usually be a rough sketch of understanding the question, right? Now we find out what is dv over dr. V in terms of r will have to be your 4 over 3 pi r cubed. So I forgot to define the variables. So we have dv over dr, which is 4 pi r squared. And then we are given that v equals to square root 1 plus t, because that's the volume after t seconds. And we can find out what is dv over dt. So dv over dt will be 1 over 2 square root 1 plus t. Okay. Then now, since we have your dv over dr and dv over dt already, our chain rule will be as such. Filling that up. We will have this. Your dr over dt will be taking this divided by 4 pi r squared. But then at this juncture, we face a problem. Okay, because your dr over dt is actually expressed in terms of r and t. What the question wants us to find is we want to find what is dr over dt when r is equals to 5. Okay, I can happily take r equals to 5 and substitute to replace this r, but I'm unable to substitute this t. Okay, so eventually I will not be able to get a value out of this if I only know r, okay, and I don't know what is t. Okay, so what we need to do to resolve this is that we know that the volume can be expressed in terms of r as 4 over 3 pi r cubed. So when r is equals to 5, I can find the volume, and that will be equals to 500 pi over 3. Okay, but my volume can also be expressed in terms of t, because there are two ways that I express my volume, either based on the radius or based on time. Okay, strictly speaking, your volume shouldn't matter despite the differences in the formula. So therefore, 500 pi over 3 should be equals to square root 1 plus t. Okay, and this will help us to determine what is the value of t. just keeping everything exact because later on I need to substitute inside here. Okay, so my dr over dt, using the substitution of r equals to 5 and then t is equals to this. Alternatively, of course, you could also observe that square root 1 plus t is equals to 500 pi over 3. Okay, so you could actually substitute just 500 pi over 3 to replace the entire square root instead of taking this t and then after placing inside here. Okay, so that means that I have 1 over 8 pi, r is 5, and then after that t, square root 1 plus t is 500 pi over 3. Okay. This will be much easier when you want to press it into a calculator to simplify it, rather than to use this value itself. Okay. So to simplify this, you just multiply the numbers. Okay, you get 3 over 100,000 pi square. Okay, that will be exact. Okay, I want us to learn how to express things in exact, but of course if the question did not specify to leave it in exact, you can leave it in 3SF as well. Okay, but I don't know what kind of situation will you be faced, that's why I want us to practice leaving things in exact as well. So what you have to do is to take 1 over 8 5 square, 500 over 3, press in your calculator. The pi, you leave it out of your calculator. So pi times pi will give us pi square. We know that it must be the denominator. Okay, so pressing 1 over 8 5 square, 500 over 3, you will be able to get a fraction of 3 over 100,000. Okay, so you just need to press, how should I write this? Press without the pi. Okay, just press the calculator without pi. Give it a try. You should be able to get 3 over 100,000. Okay. So therefore, in conclusion, when r equals to 5, your radius is increasing at a rate of 3 over 100,000 pi squared cm per second. I know that this topic can be very painful, alright? So, but then really I have no other ways that I can explain this to you anymore other than coming up with this formula. Okay, so this formula is the biggest challenge, okay, when it comes to this topic itself. Alright? Okay, I can see the pain on your faces. I can sense it also. Alright? But I really apologize, there's no other way I can explain this already. Okay, so I think, okay, if I want to give you homework, I can imagine, okay, that come back, confirm I will go through everything, okay? Okay, so now, alright, okay, let me break this topic down into smaller bits, okay? I want you to go back home, okay, go and do on full schema, okay, make sure I write this. Exercise 13.4, just go home and try and consolidate today's learning. Okay, exercise 13.4, question 3 and 4. Okay, just go and try out these two questions. Alright, Alright, tomorrow when we come back, okay, I will go through these 2 questions. Alright, but I really want you to go back home and attempt this, okay, to consolidate and give things a try first. Okay? So 2 on foolscap paper. Right, these 2 questions. So tomorrow I'm unable to actually go into your cumulative frequency or EMATS. Okay? Tomorrow the question is more challenging. Okay? But we'll start off with that first. Okay, before I dive deeper into the topic. Okay? Then that means on Thursday, then we will go into your EMATS. Okay? For today, go and give the 2 questions a try. Remember to give Meng San the money. Okay, thank you everyone.